Okay, good morning. Sorry we started a little late. I had a little car crash this morning, so I had to hurry a bit. My name's Wim Gon. I'm the owner of Cube Solutions, a Belgian-based open source consultancy company. I've been working with open source since around 1997, and I wrote things like OpenX, which is a very large advertising solution. And next to that, I specialize mostly in PHP, and I have, like most of you, I guess, a lot of certifications. Let's see who you are. Who here is a developer? Most of you, I was expecting that. System or network engineers? Okay. Any managers in the house? Oh, a few. Some of you are all three of it, I guess. Okay. Who here has experience with caching? And I don't mean installing Drupal and saying, yes, I want caching. Okay, good. Okay, this talk is titled Caching and Tuning Fun for High Scalability. I'm going to try to keep it light, but this used to be a 2-hour talk, a 2-hour tutorial, so I'll be throwing lots of information at you. I'm not going to talk about everything about caching and tuning. That's simply impossible. I'm going to give you a few techniques, a few how-tos and how-not-tos, describing basically how you can increase reliability and mostly performance and scalability of your site. The goal is basically to have a site that you can take from 5 visitors a day to 5 million without having to redo the entire architecture. But don't expect me to provide you some kind of miracle cure. If you want to become the next Facebook, you will find interesting things here, but you'll have to look elsewhere as well. Okay, we're starting off for this presentation. There's many other ways to start, but we're starting off by something that's very familiar to a lot of people, which is the LAMP stack, which means Linux, Apache, MySQL, and PHP, but it could be Python or Perl or Ruby or whatever. Basically, we have a database server, we have 2 web servers, and for our purpose, we have a load balancer in front of it. And we'll be running some benchmarks on it. I'm not going to do that live because, well, that would take a lot of time. And basically, we have a site that just runs 3 queries on the main page. That's all we're going to test for now. Our result is going to be a number of hits per second, basically. And what we test is static pages, which means could be an HTML page or a JavaScript file or an image. Anything that's static that doesn't have to be processed by the CPU in terms of dynamic requests. And we also test using PHP. Now what we see is static, of course. If we use Apache and PHP, you get a lot of hits, 3,900 on one system. And you get 17.5 requests per second on a dynamic page, which is not a lot. If we run that through a proxy, which means we're going to access both web servers, we see that the static almost doubles, which is what we would expect, but the PHP side doesn't increase. And the reason for that is that on the static part is, the limit is the CPU, network, or disk level. On the dynamic side, on the PHP side, we have a limit which is the database, basically. So we're limited by the amount of queries that our database can process. Our goal is, of course, to increase, well, both. So let's talk a little bit about caching. What is caching? Well, basically it means you take data that you have somewhere and you store it in a location where it's easier and faster to retrieve. So, for example, if you were to have, let's say, a formula, mathematical formula, and you input the same parameters over and over again, the result is going to be exactly the same. So instead of calculating that every single time again, you store that result in a cache. Makes it a lot easier, a lot faster to retrieve. If you have a certain database query and you know the data doesn't change, well then you can store the result of that data in the cache. So you don't have to execute that query every single time. How it works is, basically, your user makes a request to whatever language you're using for a certain page. And that language is going to say, okay, I have portions of that page. Let me check if I have portions of that page in my cache. It's going to request that data from the cache. Now, if the cache doesn't have the data, it's going to return false or null or whatever, indicating I don't have the data. We call that a cache miss. In this case, of course, if the data isn't there, it's probably in the database, so we're going to get the data from the database. And we're going to insert that data in the cache, so that next time we go to the cache, we ask the cache for the data, it's going to be able to respond correctly to it. Finally, we're going to output the page to the user, of course. So let's say the data is in the cache. Well, then our cache is just going to return the data. We call that a cache hit. Now we're not hitting the database anymore. We're not using the database at this point, which means we're saving on CPU resources. Now there's a couple of caching techniques that you can use. The oldest one is probably to store entire pages, which is still being used by a lot of company websites, blogging systems. Basically, this is good for any page that doesn't change a lot. The most common technique is to store a part of a page, a little block that you use and reuse on every single page, like the top 10 posts or the top 10 articles. Something that gets reused a lot is a very good candidate for caching, basically. You could store, as I showed previously, the output of an SQL query. That's also very valid. But basically, one of the things that's often forgotten is people retrieve data from database and then store that result instead of just, basically what they're going to do, they're going to reformat that data into HTML or whatever, and then they're going to send that to the user. So what's often a lot better is to reformat it and then store it in the cache in its final version, basically. So if you're doing XML parsing or you're loading a configuration file, those are all valid candidates for caching. The limit, of course, is your imagination. Basically, what you have to do is you take a piece of, you have to think, I have this piece of data. How long did it take me to create it? How often does it get updated? And how often is it retrieved? And if you balance those out, then you can find the best candidates for caching. Question is, how do you find what data can be cached? Well, I have a theory that a lot of people don't like, but I always say for new projects, start from the principle, let's cache everything. Let's try to put as much caching in there as possible. Because if you build your entire project and then you want to start adding caching, it's going to be a lot more difficult. If you build a site to be cached, if you build an application to be cached, then in general you're going to build it in a more structured way, which basically helps the entire code base anyway. For existing projects, there's a couple of things you can do. If you use MySQL, and there's a lot of other database servers that have similar features, but MySQL is a slow query log, which lists which queries take more than a certain amount of time. Those are usually queries that are very useful for caching. You can take a complete query log dump, which lists all the queries. Don't forget to turn that off, because it will not only generate huge files, but it will also cause a lot of disk writes, which will slow down everything. Or you can just check page loading times. If there's a page that takes a lot of time to process, possibly it's due to the fact that it's waiting for data, and maybe that data can be cached. Now there's a couple of locations where you can store caching data. A lot of people still store a lot of stuff on disk, usually for templates that have been compiled. It's good if you have few updates. I would never use it if you want to store the output of SQL queries. Please don't use NFS or any other network file system to store as a cache location. There's a couple of reasons for that. If you're trying to store sessions on NFS, you might get serious locking issues. Everything might be stuck. Your user might not see anything anymore because it's waiting for a lock to be released. Plus, you're running a file system across the network, which is undoubtedly going to cause high latency. Now, in any case, if you're using disk or ramdisk as a caching location, please remember you're storing it locally, which means if you have a couple of web servers, you have, let's say you have 5 web servers, you have 5 local caches, meaning it's going to be pretty hard to scale And the other problem is, how are you going to keep those caches synchronized? Please don't say on NFS or even worse, rsync. Luckily, there's a different solution. It's called Memcache or Memcache-D. And these guys are using it, which says a lot, of course. It's a distributed memory caching system. Basically, what it means is, suppose you have 2 web servers. Each of them have 64, well, it says megabytes. This should be gigabytes now, I guess. It says 64 megabytes of spare memory, each of them. If you use Memcache, then you combine that memory into one giant chunk of 128 megabytes of memory. So keys and values, all the data is spread across the memory of multiple machines. It's a key value system where the keys can be up to 250 bytes and the value attached to the key can be up to 1 megabyte. And it is unbelievably fast. You can have thousands of connections per second to it. You can have thousands of requests per second. It is non-blocking, which means you can have one connection doesn't block the next connection, like in many web servers, for example. And Facebook added UDP support, which makes it even faster. Where you install it, well, you could install it on a database server, which is usually where you take the load away by having Memcache. Or web servers. On very large installations, you install it on separate machines. And installing it is very easy. You have packages for Linux. If you use PHP, you can use PECL. And on Windows, there's binaries. And to run it, well, there's not even a single configuration file. All you do is you run Memcache-D, you give it the amount of memory, the IP address, and a port number, which is usually 11.2.11. Some quick notes. It's not fault tolerant. It spreads its keys across all the servers. By default, it doesn't provide any redundancy, which means if you lose one of those servers, the data that's on there is gone. But then again, it's a cache, so the data is not really gone. It should still be in your database somewhere. Of course, if you're using it to store session data, your users will lose their session. So you might lose shopping cart information. And another thing is that it doesn't have, well, it has built-in authentication since the latest version, but I wouldn't recommend using it. It takes a bit away of the speed, basically. I would recommend you just firewall your Memcache port. Otherwise, everyone can connect to it and get information and delete your information and so on. Okay, how does it work? Well, this is a piece of PHP code, but it looks pretty similar in other languages. If we have the Memcache extension in PHP, we can just do new Memcache. And then we have a Memcache object. We can start adding servers to it. And then, for example, we can get the key called myKey. Now, if we get false back, then that means we get a cache miss, which means the data is simply not in the cache. What we're going to do then is we're going to get that data from some database somewhere, and we're going to set it in the cache. So we're going to add it to the cache. In this case, we decide to use the same name, of course, myKey, and we don't use compression or expiration. And we can just echo it at the end. Now, if the key were in the cache, then we would just get my data back, which wouldn't be false, and we could just echo it. This is like the simplest example of caching, really. Now, we have multiple servers. We added 2 servers in the previous slide. Where will the data be? In which of those 2 servers? Well, the funny thing is the client will decide. So in this case, PHP will decide where the data will be. It will not be the server. And it does that based on a hashing algorithm. Now, there's 2 hashing algorithms in Memcache. There's a traditional one and a consistent one. The traditional one is not as good because it means that if you have 10 servers and one of them crashes, you have to rehash all the data. All the data has become invalid. If you use the consistent hashing algorithm, you lose 1/10 of the data. That's the data that has to be rehashed. So it's a little better. It's also a little faster. Okay, let's have a look at the difference. Of course, we don't see a difference in static because that's just JPEG files or CSS files. But we replaced all the queries by cache now, which means we triple in performance on a single web server. And what we notice now is that since the database is no longer the bottleneck, we do get twice the performance if we go through a proxy. There's something I want to talk about that most people don't mention when they talk about Memcache. It's a thing called slabs, which is basically why Memcache will tell you I'm full when actually there's a lot of memory space still available. Let's imagine you have a Memcache of 1 gigabyte. Then a large chunk of that will be reserved for items of up to 400 bytes. A slightly smaller one for items of up to 480. Yet again, a smaller one for items of 576, and so on and so on. Until at the end, you have a very small chunk available, a very small slab available for items of 1 megabyte. Now let's imagine you're trying to store a lot of items of half a megabyte. Then at some point, that large slab is going to be full, while the rest of your Memcache might still be free. And it's going to kick out, or it's going to evict, as we call it, data from that large slab. It's going to remove the least recently used information. Luckily, there's a couple of ways of checking that. You can just connect to it on the port using telnet, and then you can just run the stats command, and that will give you things like how many gets, how many sets, how many cache hits and misses, as well as how many evictions. It's 0 in this case. And you can also use cacti or other monitoring tools to monitor this. And what's interesting is you can do that per slab. So you can actually see that the slab for 1 megabyte objects is getting a lot of evictions, in which case you know that something's really not right. How do you back up your Memcache? Well, if you're trying to back up a cache, you're doing it wrong because you should be backing up your data, not your cache. So don't try to do that. Okay, another quick tip. Let's imagine you have a website and you have multiple blocks on there that you have stored in a cache. If you know in advance which blocks you have, then you can use something called getMulti. Actually, the command in Memcache directly is gets. And basically what happens is you supply it with a list of keys that you want retrieved, all those blocks, and the hashing algorithm will automatically spread that over the servers and say, oh, that key is stored here and that key is stored there, and it will get all that data simultaneously in one request. Beware, you might get some hits and some misses, so you have to handle that somehow. Okay, let's imagine for a second we are Amazon.com, and we have millions of products in our database. For all of those products, we have pricing information, ratings, reviews, stock information, and so on and so on. And we have a list of the best-selling or just the best LCD screens. Now let's imagine that making this query takes, I don't know, 3 seconds. Probably too much. On Amazon, it should go a lot faster. But let's imagine that without caching, it takes 3 seconds. So of course we want to store that in a cache because this page gets hit like 20 times a second. So we store that in an item called LCD Popular Product List. And at some point we decide that this price for this Toshiba screen needs to be adjusted. So we go into our backend, our administration interface, and we change the price. Now what most people would do in this case to this object is say, Memcache delete LCD popular product list, because it's gone from the cache now. So the next user will get a cache miss, and he will run that query, which will automatically afterwards insert it back in the cache, and everything's good again. Except that, in fact, this is what's going to happen. Amazon's going to go down. The reason for that is we're getting 20 hits per second on that page. If that query takes 2 or 3 seconds, then in the first second, we're going to get 20 cache misses, which is going to cause 20 SQL queries, all taking 2 or 3 seconds, which means they'll now probably take more like 6 or 7 seconds. And the next second, we're going to get another 20 hits, and so on and so on. And basically, this is what we call cache stampeding. These are PHP elephants. But it's what happens when a lot of web processes say, give me the data, and basically the database says, I can't. What's the problem here? Well, the problem is that most people build their site like this. They have a visitor site and they have an admin site. And most of the Memcache code is on the visitor side. The only part that has any link with Memcache in the admin part is delete. While in fact, Memcache code should be in the middle, and you should always be pushing updates. So if you modify the pricing information for that Toshiba screen, then you should be running that query in the admin interface and push the result to Memcache. That way, the next visitor to that page just gets the new information, the new price. There will be no cache misses in that case. So what do you do when your server has gone down for some reason, or you've had a power failure or whatever? Then basically you should have something called a warmup script. You use it to fill your cache when it's empty. And you should always run it before you start your web server. Basically, you turn off public site or you firewall your web server for a moment. There are two ways of doing this. You could visit all the URLs of your website, which is very tedious, very error-prone, basically almost impossible. Or you could say, okay, I have a list of, for example, Amazon. I have a list of all my products. I'm going to run over them, and I'm going to run all my cache updating methods, which is a very good way of testing your caching code anyway. So I really advise you to have a warm-up script for your site. Even if it only takes a minute, it can save you the cache stampeding problem. Some of you might have thought, what about locking? What if we put a lock in place when the first guy gets a cache miss? We just put a lock in place and the others just have to wait. Well, it's not a bad idea, except that while your lock is in place, you get a lot of extra connections, 20 per second. And you might get a memory spike because of extra processes, and you might see a lot of trouble taking place there. Plus, what if that process that put the lock in place, the first one who got a cache miss, what if that process fails and he never releases the lock? Then your site might get stuck. So, we started from LAMP, and we added an M from Memcache. Now let's see if we can remove Apache from this. Nginx. Who here knows Nginx? Ooh, that's a lot of people already. It's a web server. It's a reverse proxy. It's also an IMAP and SMTP server, but I'm really not going to talk about that. It's very lightweight. It's extremely fast. And it's being used currently on 9.6% of all websites. I have to adjust this slide every single time I give this presentation, and it usually goes up by about 1%. It's currently the second largest web server after Apache. It's just gone past Internet Information Server. It doesn't use any threads, and it's event-driven, which makes it very similar to Memcache. Basically, it also means that it doesn't copy its base code for every single connection pool, basically. And it uses EPOL or KQ, depending on whether you're on Linux or BSD. And to give you some idea, just if you connect 10,000 times simultaneously to Nginx, and you don't do any requests, you just connect, you're using 2.5 megabytes of memory. That's all. Try that on Apache. I've seen Nginx doing 6,000 to 7,000 connections per second, non-stop for hours, and just no problem at all. The question is, can we actually replace Apache and kick it out? Well, it doesn't support everything that Apache has. It doesn't have all these fancy modules built in. Luckily, most of them are available third-party, so you have to recompile it, but it works fine. For those of you familiar with Apache, well, server is virtual host, server name is server name without the underscore, and root is document root. So it's just a matter of syntax, really. The only thing that Nginx doesn't have is an htaccess file, which is not a bad thing in my opinion. Okay, so let's have a look at performance. What we see now is we add Nginx, and because of the low overhead that Nginx offers, we suddenly get huge performance in static requests. Anything that's images or CSS and so on. In terms of PHP processing, well, not much of a difference. What's interesting here is that these numbers are not higher because we use Apache Bench, and that uses one thread, and Apache Bench was the limiting factor here. Otherwise, we would probably get a score like 20,000. Okay, so we replaced Apache, we put Memcache on it. Let's have a look at that load balancer now. Varnish is a product that has been very popular in the last 2 years, especially for people who are running Drupal. Who here is running Drupal? Not a lot of people. That's good. It's more than just a load balancer. It doesn't just, send one request to one server and the second one to the other one. No, it's a reverse proxy cache or HTTP accelerator. There's plenty of names for it. It caches pages or parts of a page in memory, not in Memcache, in internal local memory. So if you have multiple varnishes, you have one cache for each varnish. You have to be careful though. It uses threads like Apache, but it doesn't use as much memory, so it's not that much of a big problem. And Nginx usually scales a little better, but doesn't have a thing called VCL, which we'll see in a moment. This is the configuration. It's very simple, actually. You just add a backend, which is basically the web server that's running behind it, and then you basically join those two backends in what we call a director. That's all the basic configuration. It does have a thing called VCL, which is the Varnish configuration language. It's a domain-specific language. It's very specific to Varnish, and it compiles itself to C automatically, which makes it very fast. And it will attach itself to every single request that you make. And you can do things like remove cookies, change headers, have ACL systems. You can do flood detection and automatically ban people if they hit your site too often, and so on. And you can reload that while running. You can also do that with Nginx, by the way. It has very fancy command line stats and graphs. And it has a thing called ESI. Now, ESI is called, it basically means each site includes. It was developed by Akamai Technologies, the content distribution network. And it's the ideal thing for caching static pages. Basically what it means is, suppose we have a big article content page. We probably have multiple blocks on that page. We have a header, we have navigation, we have the hottest, latest news, and then we have the actual content of our page. And we would like to store that in a cache, but we'd like to store the latest news for only 2 minutes because that needs to be updated a lot. Now, ESI allows you to do that. What you do is basically in your HTML of your main page, you put a little HTML tag like that. ESI include source equals news. And what's going to happen is Varnish is going to make a sub request to /news. It's going to fetch just that and put the output instead of the ESI tag. Now the big advantage of that is the first time it's going to hit this page is going to hit your web server 5 times. 1 for the main page, 4 times for each of those separate sections. Second time, it's not going to hit your web server at all. It'll take 2 minutes when the TTL of /news has expired before it hits your web server again. In the configuration, it looks a little like this. You're going to define each URL /news. You're going to say, I'm going to do ESI processing, and please store this for 2 minutes. Okay, what's the result? Well, we're going to see that statically, not much of a difference. Again, Apache Bench limit. Dynamically, look, we've increased PHP performance. Then again, wait a second. This is not PHP. This is not dynamic requests anymore. We're caching stuff. /news is being cached for 2 minutes. So if we have dynamic content, that's not really going to work. So what can you cache? Well, you can cache anything that's static. Static pages, JavaScript, and so on, or any part of a page that doesn't change often. You cannot cache post requests, quite normal. It's not a file server, so don't store very large stuff on it. And you cannot cache anything that has cookies, which means anything that's user specific. So, in this case, I'm logged in as me and I have 5 messages. I might be able to cache that left part, which might be navigation, or the main content, which might be an article. That part, that's user specific. Varnish cannot cache that because it would need a TTL of 0 seconds, because I might have 6 messages in 2 seconds. I might have 10 messages, and so on. So, up till now there was no solution for that. However, we built something on Nginx, which reduces the load anywhere between, let's say, 50 and 95%. It depends on your site, really. And it works very well on web and database servers. This is the result that we had at one customer on one of their web servers. That's the result over a week. Basically, what we did is, our first customer, we were able to reduce the total number of servers from 24 to 6. And we had a second one where we reduced it from 87 to 12. They were already using Nginx and Memcache, so we had a bit of a challenge there. We're running it at 2 customers, and we expect to release this thing somewhere by July, and we hope to be able to release it completely as open source, of course. So this is something that's coming up. Okay, so we did a lot of caching, we modified the stack a little bit. I want to talk quickly about some speed tips, some tips and tricks. If you're using PHP, who here is using PHP? Okay. Really, upgrade PHP, please. Every single minor release has a lot of speed improvement, and the next one, which will be PHP 5.4, is going to get anywhere between 25 and 50% speed improvement because of a lot of optimizations. So I really recommend you do that. Use an opcode cache. If you don't use one yet, APC is an example of an opcode cache. Basically what it does is, instead of recompiling your PHP script on every single hit, it's going to do that once and then store it in a cache. And it will only recompile it again when the script is changed, basically. So that's going to save a lot of time. It can improve performance between 5 and 10 times. Database. If you're doing joins, for MySQL, I'm not sure if it's the same in every database, but I think it is. If you're joining an int field in a decimal field, it will convert your entire table, all the ints, into decimals, which is going to take a very long time. So try to join on the same types. I don't think I have to tell you that order by rand is very evil. And if you're using MySQL with InnoDB, and you're doing count asterisk, and you don't use a where clause, then you're doing a full table scan. Something not a lot of people are aware of. They're going to fix that, but in the current InnoDB version, it will cause a full table scan if you don't use a where clause. And persistent connections, they're sort of evil, especially if you use Apache. Apache has the tendency not to release certain connections, so if you have a lot of persistent connections that remain open, you might run into trouble pretty quickly. Okay, I want to talk. Who here is a backend developer, backend engineer? And who is a frontend engineer? Not a lot, as expected. Still, I want to talk about frontend very quickly, because this is a graph showing from 1995 to 2009 the number of objects on a page and the size of those objects. As you can see, that grows, which means you as a backend engineer, you might spend a lot of time optimizing it, and then your front-end engineer comes along and he sends 15,000 AJAX requests per page, and your site goes down. Please remember, your front-end sends requests to the back-end. So as a back-end engineer, you really need to focus on the front-end as well. You need to at least test and check what your front-end engineer is doing. And if they don't know what they're doing, well, maybe you can help them out. You can tell them to minimize the number of requests by combining CSS files, by combining JavaScript files, or by using CSS sprites. Who here uses CSS sprites? Oh, okay, a few. This is a CSS sprite. This is one image, And this contains all the images for the Google site. This is a famous one, sharing one. Amazon has one, YouTube has one. Basically what happens is, let's imagine we have 11 images and we're using all of those on our site. Now if we want to download those, we need 11 HTTP requests or 24 kilobytes of data. If we group those together in one image, we get one HTTP request, and because of PNG compression, we get only 14 kilobytes of data. So imagine you have 1 million visitors a day. Well, you can do the math. That's a lot. And what happens basically is you can combine these images using a lot of different tools. There's plenty out there, and they will automatically generate CSS that will set the position of each image automatically. Put CSS at the top, that way your site will at least look well while it's loading. And put JavaScript at the bottom. A lot of people still don't do that. The reason I mention that is your browser has a maximum number of connections that it can open. If it reaches that limit, it will not open another connection until one has closed. Which means if you have a lot of advertising scripts and they're doing calls to external websites, your site might possibly block. Avoiding iframes, well, the same reason. Your iframe will load inside your page, and within that iframe, maybe you load more and more stuff. So try to avoid iframes. I don't have to mention this, I think. Don't try to scale images in HTML. This is a fun one. If you don't have a favicon.ico, that silly file that Internet Explorer introduced, you might run into serious trouble. That could actually bring down your entire site. I have an article about that on my blog. It would take a lot of time to explain why. But if you're interested, you can go there and read it. But just trust me, have a favicon.ico, even if it's only 0 bytes. So what else can kill your site? Well, anything that has to do with redirects. Basically, you're sending your user to a different location, which means he's going to hit the website again, he's going to make another request, he's going to put more load in your system, and there will be more stuff to process. And you're delaying him. You're sending him to another location, he has to make another request, and so on and so on. Just in general, try to avoid any redirecting. In most languages, you can have some kind of a forward system instead of redirect, so that you can internally, inside the code, forward people. Now, we all have logs, or we should have logs, and that's important. It's important to watch those logs, to keep an eye on them, which most people don't do. But it's also important to keep an eye on the process that is logging. If you have a very busy website, then the logging process alone, causing all disk activity, can actually bring down your server and your site. I guess a lot of people know the /dot effect, or should we call it the Reddit effect or the Facebook effect now, which is basically what happens when 1 million people hit your site. But basically, the main thing about keeping everything online is be prepared, have a monitoring system. If you have one server, well, it's probably not worth installing a monitoring system on a separate system, but there's a lot of SMS monitoring services out there that will cost you like €2 a month. It's worth it. If you use caching and you're doing disk, you want to start with disk caching, you don't want to go to Memcache yet, then make sure you can easily move to Memcache without having to rewrite all your code. It saves you a lot of time. If you go home tonight, don't start installing Varnish, Nginx, Memcache, the whole thing. But you might want to experiment. You might want to have a test setup, have a couple of VMwares maybe, or virtual boxes, and set those up, prepare everything just in case, so that you at least know how it works and how well it works. And finally, have fallbacks. If your site suddenly gets hit by 1 million visitors a day, you should be able to turn off stuff that you don't really need. Maybe you don't want that XML feed to update every 2 seconds. Maybe you don't want an AJAX request that updates some kind of news ticker every second, and so on. You should be able to turn off anything that keeps it offline. That's basically the main goal, to stay online. Okay, any questions? No questions. Ah, up there.
Implementing a web server in PHP itself is faster than running Apache or any other web server in front of it.
Well, actually, in PHP 5.4 there will be a web server, but it's designed only for testing purposes, for development purposes. You're right that using Apache makes it a little slower. What we noticed is that there's a new system since PHP 5.3 called PHP-FPM, which you can link to Nginx, which makes it a lot faster, which scales much better, and which has a lot of other fancy tools. But there's definitely some work to be done there, but it's getting there slowly. And we have some speed improvements in 5.4, so I really recommend installing that version, really upgrading to it.
Okay.
Any other questions?
Yeah, I have another question. So there is another tool called Redis. Can you? Yeah, I have another question. So there is another tool called Redis. Can you elaborate and compare it with Memcache-D? So in terms of using it for cache.
Sorry, which tool?
Can you compare Memcache-D and Redis?
I don't understand.
Yeah, do you know the tool called Redis?
Oh, Redis.
Yeah, can you compare it with Memcache-D?
Well, what I've noticed is that Redis is a very nice tool. It works very well. It has persistent storage. Oops. Oh. Has persistent storage capabilities as well, which makes it very, very interesting. It appears that for anything that's small objects, Memcache is slightly faster. If you store a lot of large objects, Redis tends to be a little faster. And in terms of reading and writing, Memcache is faster when it comes to a lot of updating. If you do only reads, then Redis, in some cases, can sort of match Memcache in terms of performance. But if you're doing a lot of updates, because of the fact that in Redis you're doing persistent storage as well, it tends to be slightly slower. Okay. Sorry?
Right. So, sorry, I have a question. Hello?
Yeah, there's another one there, but apparently the microphone doesn't work.
Okay, I'll ask first.
Sorry, I have some?
You mentioned the limitation of Apache benchmark.
Yeah. Well, the limitation basically is that Apache is single-threaded. Apache Bench is single-threaded. And so if you're trying to benchmark a site like that, you reach the limit of your CPU at some point, which is why we couldn't go any faster. If we had tested using a faster system, it would have gone higher probably. Yeah, absolutely, absolutely, yeah.
Did you ever have to do optimizations on system switch to graphing, like Monin or Graphite?
I'm sorry.
System switch are dedicated to graphing, so monitoring metrics.
I don't really understand what you're doing.
Basically, your problem is you're hitting a lot of files to update metrics, and you also have a lot of users querying a website which basically has a lot of graphing to display. So did you ever have to overcome any of this?
I'm afraid I actually can't hear you very well here.
Okay, do you want me to come there?
Yeah. Okay, basically, for those of you who want the slides, I'll put them online. I'll tweet as well about that. So thank you very much.